All right, we're going to see how fast we can knock out this battleship code. First of all, in part 1 here, we're building the ship class, and they've given us a little bit to go on here. The instance variables that we need and some constants and whatnot. So we're going to go ahead and just copy this and paste that on over. And the instance variables, private int row, and we're going to set that to unset. That's kind of one of the advantages of having those constants with meaningful names. And then private int column will also start off as unset, and private int the length of the ship will start off as unset, and private int direction is also going to start off as unset. Okay, and then our construct, all of this that they want us to put in there, and we're going to throw it in over here. And let's slide all that over one tab. And this battleship doesn't need to be there. Okay, so for the constructor, all we need is a parameter for length. Now, I don't like it when the parameter has the same name as our instance variable, so I'm going to make the parameter the length, and I'm going to say our instance variable length is equal to the parameter the length that they set us. But we're going to need some more information before we can set the row, column, and direction, so we're going to leave that unset. Next thing is a Boolean, is location set. So if row equals unset or column equals unset, then the location set is false. Otherwise, we will return true. Okay, so that's just a really quick thing to see if the location is set. Then, has the direction been initialized? Well, once again, if direction is unset, then we return false. The direction is not set. Otherwise, we return true. So that's pretty quick. Set location. So on this one here, I would rather call these something else other than row and column. Let's call that R and C, and then we can say row, the instance variable, equals R, the parameter they passed us, and call, the instance variable, equals C, the parameter they passed us. Set the direction. So let's just call that D, and let's say direction, which is our instance variable, equals D, which is the parameter they passed us. And then for get row, all we have to do is return row. And for get column, all we have to do is return column. And for get length, all we have to do is return length. So those are really quick. And getter for direction. Now so getter for direction, once again, all we have to do is say return direction. So that's all pretty straightforward. Now, direction to string. All we want to do here, well, we got to have three things. If direction equals horizontal, then we will return the string horizontal. If direction is vertical, then we will return the string vertical. And if both of those fail, then we're going to return the string direction is unset, or something to that effect. Okay. Then location to string, we want to return parentheses, and then whatever our row is, and then a comma, I think a comma and then a space, and then whatever the column is, and then the end parenthesis. I think that's what we want to return for location to string. And then for the to string, I think we want to return something like this. Ship of, let's say this. Let's say direction to string. So that'll be the word either horizontal or vertical. So let's say vertical ship of length, and then we want the actual length of the ship. And then we're going to say at, and then we're going to say location to string. And that has, double parentheses after it. This one over here should have had double parentheses after it. And I think that's all we want to do there. Let's just run the code real quick to see if we missed a semicolon or something. Okay, so that works fine. Now let's really quickly in the ship tester, let's just create a ship or two. Capital ship, let's call it S1 equals new ship, and let's say it's a ship of length 5. And if we do system.out.println S1, then we'll see what that looks like. Direction is unset, ship of length 5 at -1, -1. So the position, the location, I should say, and the direction is unset. So ship 1, set location. Let's make the location 5, 2. And then let's reprint that out just to see what we have now. Direction is unset, ship of length 5 at 5, 2, so that's okay. And then let's ship 1 set direction to 0, and then once again print out ship 1. So now that its direction is set, it says horizontal ship of length 5 at 5, 2. So we might have to clean up a little bit of the strings and whatnot, but I think that's basically all that we need to do. So expected result, unset direction. So over here, unset direction. They want this to say unset direction, ship of length 3 at unset location. Location to string. So we need to add a little if statement in here. If, what did we say up here? If is direction set, if is direction set, then we can return this string. Otherwise, we're going to return, what do they say there? Unset location. Okay, so I'm trying to set up the unset direction string, so that looks like what they're expecting, and we didn't have anything to handle turning the location into a string if the location was not set. So now we're doing that. Oh, and we want to do that in parentheses, it looks like. Okay, so let's check that now. And that looks all good. So there's part one of the creation of Battleship. Okay, so on part two of Battleship, we're creating the location class. And they tell us that we want to have some constants. So let's just copy that and put that over here somewhere with appropriate tabbing. And here are the methods that we want. So basically our location class is keeping track of if we have a ship at a location and if a location has already been guessed and whatnot. So the location constructor, we don't need any parameter to create a location. So we can just say that. So it looks like, according to this, we need to have two instance variables. We need a private Boolean that we'll say is called has ship, and we will initialize that to be false because when a location is first created, there's been no ship placed there yet. So then we're also going to have a private integer called status, and we're going to start the status off to be 0, which is unguessed. So we should probably put up here a little comment that these are possible statuses or stata. So any location, it starts off as unguessed, and then once it gets guessed, then the guess is either a hit or a miss. So that's going to be our status. Again, we don't need any parameter for the constructor. For check hit, and this is a Boolean, so if status equals hit, then return true, meaning yes, we're verifying that it's a hit. Otherwise, we're going to return false. Hopefully all of these will go that quickly. Check miss. So same type of thing. If status equals missed, then the check miss is true. Otherwise, we're going to return false. Then is unguessed. Well, if status equals unguessed, then that means is unguessed is true. So return true. Otherwise, return false. Okay, then mark hit. So when we mark a hit, we're just going to say the status is equal to hit. We're going to assign the value of hit to status. And if we're marking a miss, then we're just going to assign the value of missed to status. And for the Boolean has ship, we're just going to return, I don't like that this method has ship, and we have a variable called has ship. So let's change this Boolean variable up here. Let's make this something like ship here is false. And also this status here that's 0, let's go ahead and use our constants that we have defined up here and say status on. So for the has ship, then all we have to do is return ship here. Ship here will be true if there's a ship at that location, so we're just returning the value of our Boolean ship here. Then our Boolean instance variable ship here, we will set to whatever value they give us, true or false, for that set ship. And then set status, we will just say the status of our ship is, let's call this S instead of status, or you know what, let's call it the status. Status, our instance variable, equals the status, the parameter that was given to us. And then only one more, public int, so this is a getter. That means we're going to return status. So that's the only one that's a getter in this whole thing. And I think that's all we need to do there. We could create a new location if we wanted to. Location L1 equals new location. No parameter necessary. And we could do a couple other things here, I suppose. System.out.println L1 has ship, which should be false. And system.out.println L1 is unguessed. That should be true. So let's see if this runs without error. And we get a false and a true printing out here. And I think that's all we had to do for the location class. I'm going to double check everything, but it looks like we're good there. So far that's part 2 down. Now moving on to part 3. Okay, in part 3, we're going to create the grid class, which is going to basically be a 2-dimensional array of location objects. So they want us to have these variables here for sure. Let's put this over here in the grid class. And actually, oh, I got this in the wrong spot. Actually, I would like to have these constants up here at the very top. And then, so every grid class is going to have a 2-dimensional array of location objects. And before I get too far carried away, I'm going to have to copy our code over from before. So we're going to have to bounce back over to part 1, where we created the ship class. Click on the ship class, click in the code window, Control A, Control C, and then back to part 3. Click on the ship class, click in the code window, Control A, Control V. And then back to part 2 so we can grab the location class. Click on the location class, click in the code window, Control A, Control C. Bounce back to part 3 and click on location, click in the code window, Control A, Control V. Okay, so back to writing the grid class. We've got that. To start off with, implement the basic functionality. And let's just copy all of this. And we're going to paste it over here. And we have a lot of work to do, but I don't think it'll be too bad. Let me tab all of this over. Okay. So the grid object is going to be a 2-dimensional array of location objects. So up here, instead of just saying location, a double array of location objects called grid, let's call it a new location. And in here, we're not going to put 10, even though we know it's going to be 10. We're going to put num rows and num calls. That way, if we wanted to change this to a 5x5 Battleship grid for some reason, we would just have to make the change up here, and then everywhere else in our code it'll say num calls and num rows. Okay, so here's what we need to do in our constructor. We need to create a location object. So we need to create a location object for every spot in our two-dimensional array. For int I equals 0, I less than num rows, I plus plus, and then another loop for int j equals 0, j less than num calls, j plus plus. So every time through this loop, we're going to say our grid at location ij is a new location object. And remember, our location object, our constructor for the location class, doesn't need any parameter. So we're okay just saying new location. So this loop will initialize the 100 location objects that we need to be in our grid. So then when we say mark hit at a particular location, so our grid variable at location row and column, remember our grid variable is a two-dimensional array of location objects. So the grid variable at index row and index column is a location object. And remember, a location object has a method called mark hit. So in our grid method over here, we're going to call that location method mark hit. So in the spot in our array at row and column, whatever location object that is, we're going to say mark hit. And we're going to do that type of thing several times here. Our grid variable at index row and index call, we're going to say mark miss. And again, that's a method of our location class already. Right there, mark miss. Okay. And then set the status. So once again, our grid at this index, row and column, that at that location in our 2D array is a location object, and that location object we can set status, and we can set the status to this parameter that was given to us there. And here we're going to return the status of the location object at this row and this column. We are going to get status and return that. So remember, our location class over here has a, where is it down here, has a get status method, which we're using over here in the grid class. Okay, we're getting there. And then already guessed. So this is going to be a Boolean. Return our 2D array of location objects at this index and this index. That location object has a method is unguessed. So we're going to use that, but we actually want to say the opposite of that right now. If it's unguessed, then we want already guessed to return false. And if unguessed is false, that means it has been guessed, so already guessed should be true. So basically, we want to return the not of whatever this is. Let me see what else we've got going on here. Okay, then we have set ship. So our 2D array of location objects at this index and this index, I think it's called set ship over there. Location, it's called set ship. So we're going to say set ship, and we're going to set the ship to the Boolean value that we've been given right here. Okay, then we're going to return whether or not we have a ship at this location. Grid at row and column. We're going to return whether that location has a ship. And in our location class, that's called has ship. So over here, we're going to return this location has ship. And then, and notice this one, this method is returning a location object. So remember that our two-dimensional array called grid is an array of location objects. So if we simply refer to grid at this index and this index, that's a location object. So we're just going to return that location object. I think that's all we want to do there. Okay, and then the next two are really simple. Public int num rows, just return our constant num rows. And public int num calls, just return our constant num calls. Okay, so let me just, before we get on to the next one, let's just make sure that is all running without error, so I didn't miss a semicolon anywhere. Sure enough, okay. No, this is down here. So we have those two methods yet to finish. Okay, so now, when we have a grid and we want to print the status, we need to print out something that looks like this. So first of all, let's go back up here to the top. There's one other constant that I want to create, and I'm going to call this public static final string called row underscore names. And I want the row names to be an array of the letters of the alphabet A, B, C, D, E, F, G, H, I, J. So in other words, our 2, 3, 4, 5, 6, 7, 8, 9, 10, our rows in our array are going to be numbered 0 through 9. But I want those rows to have names of A, B, C, D, E, F, G, and so on, because that's how the board game is played. So I'm making an array of row names so that I know when we're in row 0, that's going to be the letter A. And when we're in row 9, that's going to be the letter J. That's going to make several things in our, I guess you would say in our printout, go a little bit more smoothly. So for print status, where are we at here? For print status, here we go. First of all, we're going to print out a row of numbers, which are the headers for all the columns. Print line. So we want this to print out right here. Everything over to about there we want to print out. So that's the first thing we're going to have to print out. Then we're going to go through a couple loops. For int I equals 0, I less than num rows, I plus plus, and the very first thing we want to do when we're printing out the rows is we want to print out the row name. So we're going to say system.out.print, not print line, row underscore names at index I, which will be the letter A or the letter B as appropriate, and then a plus sign and then a space, so that we get something like this and this. And then we're going to go through another loop, int j equals 0, j less than num calls, and j plus plus. And then we want to print, let's just do this for right now, system.out.print line, not print line, just print. Let's print right now just a hyphen and a space. Okay? Just pretend like everything's going to be these hyphens for right now. And then when we're done printing out those 10 hyphens, remember we did print and print, so now to go down to the printing out the next row, we want to have a print line statement. And I think that'll somewhat get us what we want. So, for example, if we go over here to our grid tester, we can say grid, let's call it G1, equals new grid. And then we should be able to say G1 dot print status. And we should see, if we do print status, we should see something looking, where am I at? Something looking like this, more or less. And I'm going to get an error down here if I don't have my little braces. Okay, let's see how this looks. Okay, so I think that's kind of what we want the grid to look like, more or less. Now we just need some code in here. We need some code right here that's going to not always print out a hyphen, but print out some character to indicate whether it's a hit or a miss or unguessed. So if it says already guessed, so we can say if not already guessed, and already guessed at location index I and j. If it's not already guessed, I love it when the names of variables and methods make a little bit of sense, like linguistically. If it's not already guessed, then we're going to print out a hyphen and a space. Then we can say if it's missed, get status. We want get status. I'm just realizing it would have been really helpful if we brought in some of our constants from over here. If we had some of those constants over here, that would be kind of sweet, because then we could say if the get status, so if get status of this row and this column, if that is a hit, then we're going to do system.out.print, and we're going to print an X and a space. And then we can also say if get status of location I, j, if that is a miss, and I could have just done this as an if else, but I'm just doing it as 3 separate else's. If that's a miss, then system.out.print, and I think they want an uppercase letter O and a space. I couldn't tell at first if that was supposed to be an uppercase O or a 0, but I think they want it like that. So let's see if this, how this goes here. Get status equals, it doesn't know what miss is because it's missed, not miss. Okay, so there's our status. So then let's go back to the tester and let's add a couple more lines of code over here. So we got a grid and we printed out its status. Now let's do some guesses. Let's mark a miss at location 1, 1. I'm going to pretend like I'm going down the diagonal, actually starting off at 0, 0, because when I play Battleship, for whatever reason, I like going down the diagonal. So let's mark a miss at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. This is not getting graded. I'm just trying to make sure our print operation, our method called print status, works. So if I mark all of those as a miss, and then I say grid 1 print status, and I might want to have an extra line in here somewhere. So let me do a system.out.print line, a blank line there. So now it's going to print status twice. Once when the grid is first created, and once when I've had a bunch of guesses. Okay, so it looks like the print status is working just fine. We could add a couple of hits in here if we wanted to. Mark a hit at, let's say, 1, 8. And let's mark a hit at 2, 8. And we can see what that looks like with a couple X's, hopefully. Okay, so that method is doing pretty much what we want. So then the only other one we have to implement, which is going to be very similar, and I think because this is going well, I don't think I need all of that comment anymore. And then we want something very, very similar down here. So I'm going to copy what we have here, copy that, and I'm going to paste it down here. So if we're printing the ships, we still want to print out that header of column names. And at the beginning of each row, we want to print the row name. But now this if is going to be a little bit different. Now all I want to know is if there's a ship at that location. So if has ship, remember we wrote a method up here called has ship somewhere. If has ship, that's a Boolean. So if has ship at location ij, then we will print out an X and a space. Otherwise, system.out.print, we will print the hyphen followed by a space. So I got all that, and at the print line, I think that's all fine there. So I'm going to try this out with a different grid. So on my grid tester over here, let's do another blank system.out.print line. Okay, and then let's create another grid called G2. And on G2, I'm going to set the location of my ships. So I'm going to say G2 set ship. So set a ship at location 1, 1 to be true. And similarly, let's make it a ship of length 5. So at 1, 1 and at 1, 2 and at 1, 3 and at 1, 4 and at 1, 5, set a ship in all of those locations, and then G2 print ships. And let's see what that looks like. So all the stuff with G1 should be okay. And so there's G2 that has a ship at 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5. And maybe I should put here as a comment just to remember that when in terms of our grid, because our two-dimensional array is 0 indexed, location 1, 1 is actually the second row and the second column, because the first row and the first column is indexed at 0. So this is actually B2. And then this is B3, and so on. And we could set another ship. Let's say set ship at, let's go over to 5, 6, make that true, and 5, 6, and 6, 6, and 7, 6. So A, B, C, D, E, F, that should be F7, and this should be G7. So this one's going vertically, and this should be H7. Let's see if that looks right. So it looks like the setting of the ships is working okay. So unless we missed a space or something somewhere, I think this is all doing what we want it to do. Let's check it out. Okay, what is it not like? I either have an extra space or I'm missing a space. So let me try this. I think I have an extra space right there, and an extra space likewise right there. And again, I don't need all of these comments because I already have this pretty much looking the way I want. So let's test this again. I think that space will take care of part of these errors. Oh, everything's good now. So it was just that one space that we had in 2 different spots. So that's the end of Battleship Part 3. We've done the grid class. That was the most time-consuming one so far. All right, so in Part 4, they just want us to add one method to our grid class, which is called add ship. But they don't copy all of that code over, so we're going to have to do it ourselves. So going back to Part 3, click on ship, click in the code window, Control-A, Control-C, back to Part 4, click on ship, code window, Control-A, Control-V, back to Part 3, click on location, in the code window, Control-A, Control-C, back to Part 4, click on location, in the code window, Control-A, Control-V, back to Part 3, the grid class, click in the code window, Control-A, Control-C, and then back to Part 4, click on the grid class, click in the code window, Control-E, Control-V. Control-A, Control-V, that is. So if we copied all that over correctly, that should run without error. Also, just for jollies, let's go back here and our grid tester. I'm going to copy all of this and then go back to Part 4. And in the grid tester, I'm going to put all of that code just to make sure everything's still working the way it's supposed to work. I'm probably going to delete all of that, but I just want to make sure everything's working the way it's supposed to work. Okay, now we're supposed to add a method called addShip. So in our grid class, we're going to go down here almost to the bottom. I'm going to put this almost at the bottom, but in front of our print methods. So I'm going to place it right in front of print status. So addShip. This method can be called on your own grid. To add a ship, we will go to the ship's location and mark true for every value, every location that the ship takes up. So they're giving us a ship object S. And I would like just to streamline the code a little bit, or I guess make the code a little bit easier to read. I'm going to get some information about this ship that we're supposed to be adding. So I'm going to say a new variable called row, which will be the ship get row, and a new variable called call, which will be the ship get call, and then a new variable called length, which will be the ship get length, and then a new variable called direction, which will be the ship get direction. Okay, then if the direction is horizontal, then we want to do one thing. Otherwise, we want to do something else. And by the way, we copied and pasted. Oh, I don't have horizontal in there. Hold on just a second. We need to copy over. So we got guessed and hit and missed, but we don't have horizontal. So let's go over here to location. No, to ship. And let's get those variables there for horizontal and vertical. And then come back to grid and paste over here for unset horizontal and vertical. Okay. All right. So now, if, that way I can write my code looking like regular language. If the direction is equal to horizontal, then here's what we want to do. We want to go through a little loop. I equals column, I less than the column plus the length of the ship, and then I plus plus. Maybe I can call this C instead of I. Okay. So I want to start off in the column. I want to start off in the column where the ship is located, and then I want to move across to other columns depending on the length of the ship. So let me see if I can show an example over here. So for example, this ship is located at 1-1. And so I want to go through a loop to mark 1-1 has a ship, and then 1-2 has a ship, and then 1-3 has a ship, and then 1-4 has a ship, and then 1-5 has a ship. So that's what we're trying to do here. So our grid, I don't even have to say grid. I can just say set ship at location row, not row comma call, but row comma C, because I want C to change every time through this loop, and we're going to set this to true. That's all I have to do. Go through a loop and set this location to true, this location to true. Remember, it's the C that's moving, so it's my column that's moving. The row is staying the same, my column is moving. Otherwise, we're going to go through a very similar loop, but now it's the row that we want to change. And we want the row to be less than this location row plus the length of the ship. And then R++. And, oh, I said get ship up here. I want to say set ship. And then down here, we're going to say set ship at row, which is now R, and column, which is col, and set that to true. So let's just first check for any errors. Okay, we don't have any errors. So now let's do this. So let's go back to the grid tester and change up what we're doing a little bit here. Instead of, so we're still going to create a grid number 2, but instead of setting the ship location individually like this, in other words, instead of setting the ship of length 5, instead of us setting the location 5 times, let's use the method that we just created. So suppose we create a new ship. Let's call it S1. And it's a new ship of length 5. And where did we set its location? To 1, 1. So S1 set location to 1, 1. And S1 set direction to horizontal. I don't know if I can say that if I don't have those variables up here. I don't have those variables up here. So let me bring my horizontal and whatnot ship. Let's bring that over here. Bring that over to the tester. Okay, so I can say set direction to horizontal. So now I'm creating a new ship with length 5. I'm setting where its location should be, and I'm setting that it's going horizontal. So now I should be able to say grid 2 dot add ship, and the ship I want to add is S1. And then that little loop that we wrote will take care of setting all of these to true. So if I just do that and say print ships, I should see this right here. Let's see if that works. Okay, beautiful. Let's do another one just for the heck of it. Let's create another ship, call it S2, and let's say this is a new ship of length 3. And S2 set location at 5, 6. I'm just trying to replicate what we did before. And S2 set direction to vertical. And then on grid 2, add ship. What ship do I want to add? Ship 2. So now we should see over here at 5, 6, we should see a ship appearing right here. Okay, so I think we have the add ship method working correctly, and that's frankly all we had to do here, so this better check out okay. All right, that's beautiful. So now we're on to part 5. And Battleship Part 5 is the player class.